quick introduction about myself. My name is Ganesh. I'm a principal technologist, work for Relic. And as the salt, pepper, hair must have already given it out, I have about 16 years of experience in observability, DevOps, SRE, and information security. I've done my adventures. And when it comes to personal likes, I read a lot about Indian mythology, and I'm a huge fan of stand-up comedy. Two different things, right? Two different things. So to start with the agenda for today, what we're going to talk today is about how important it is for you to read the right data in the right manner to get the most out of it, explore the complete potential of it. And once you know what data to capture, what are the observability tech stack patterns that you have that you can choose from to make the most out of it, right? And then we will also look at the challenges that the companies will face when they scale their business from X to 10X and which patterns can they follow. And we also will look at what are those strategic decisions that they can take with these different patterns so they get the most out of the telemetry data that they're capturing. And the last one, how efficient you can get if you use Relic, right? So the title of this session that you're seeing in the catalog that was given to you, you must have, it says driving O11y from X to NX, right? And then it says investigating bullet holes, not breaking those. Too many analogies, too many acronyms that one person can handle in a day, right? So, but I'll make it simple for you, right? And I'm going to make it simple for you through a story. How many of you recognize this picture? 1, 2, 3, 4. Okay, for others who do not recognize what this picture is, what looks like on this screen is a fighter jet that belongs to American Army, and the situation is from the World War II times, right? So American Army would send these fighter jets over to the Europe for defense purposes, and what they found is the survival rate of their fighter jet planes started dropping. So they've put together a specialized group of team and then said, tell us how to increase the survival rate. And what's the first thing that anyone would do? Analyze the data that they already have, right? So they started looking at the planes that came back. The first thing that they found was the number of bullet holes at the tail end are more compared to the number of bullet holes at the nose end. So obviously they said, you know what, we need to add a lot of armor at the tail end. The army don't want to add the armor all over the place, all over the plane. The reason for that is it's going to be super costly, right? Basically breaking the army's bank. They don't want to do that, and the specialized group, based on what they said, they decided to add armor at the tail. But there is a mathematician by the name of Abraham Wald, and then he said exactly the opposite. He said, we should not be adding more armor at the tail, but we should be adding more armor at the nose. And the reason for that is the planes that actually got hit at the nose never returned. So basically the number of planes that are getting crashed because they got hit at the nose are more, right? So we need to add armor more at the nose side. The takeaway from this story is you have the data in front of you, but are you looking at the right data in the right way or not? And if you are not looking at it, are you taking the right decisions? Or is there any missing data that you really need to read so that you can take the right decision or not, right? And this is not a challenge that just the American Army faced. This is the challenge that almost all the organizations are also facing as on today, right? And the challenge that they are facing is as they continue to evolve their architecture, add more moving parts, the complexity of the architecture is increasing, right? And there are a lot more unpredictable failure modes, lot more dynamic failure modes. And that is where the standard monitoring is falling short. And that's where you need a full stack observability, right? It's just not monitoring, but a full stack observability, right? So what we're going to do is, we know that full stack observability is important, but what are the patterns that are available for any organization to look at when they want to implement full stack observability, right? Let's start with the first one, which is DIY. What's DIY? Do it yourself, right? Do it yourself. My wife is a huge fan of do it yourself. She does a lot of stuff at home and avoids and stops me from buying stuff. So yeah, do it yourself. Do it yourself is where you use a lot of open source solutions. You might be using OpenTelemetry for tracing purpose. You might be using let's say Grafana or Prometheus for capturing metrics, right? But what's happening here is, because all of these tools serve a specific purpose, the data goes to that specific tools, right? That's DIY. And then we have SaaS. SaaS is where you sign up for a specific commercial model with one of the vendors, and these vendors come up with their fancy proprietary agents, which you can take, install it as part of your tech stack, and all of this would send the data to one place, right? Be it any layer of your tech stack, everything together to one place. And then comes cloud. Most of the open source solutions that you have as on today are also taken by the cloud providers, and then they are offering these as managed services, right? So they host the solution on their side and then they charge you for it. Even if the data is being collected and then sent to just cloud, they still have a challenge because the data is sent to different services within the cloud. For example, if I have to take example of AWS, all the tracing data goes to X-ray, right? All the metrics and logs data goes to CloudWatch. And the last one is hybrid. Hybrid is where you're using open source or you're signed up for with a proprietary vendor, but you're also using the other side of it for very specific use cases, right? So to give you a rundown of all four in layman language and other examples, DIY is like you bought a car, you're driving it by yourself. SaaS solution, you bought a car, but then you hired a driver to drive it for yourself. And then cloud is where you did not buy a car, you did not get a driver, you're just booking it on Uber and Ola, right? And the last one is hybrid. You own the car, you also have a driver, but you will also hire a car or a driver for long drives, special purposes, right? People like me who hate long drives. I hate long drives, right? And then, so we understood different patterns of observability. Now let's change the track a little bit, right? Now let's see how the businesses are scaling as on today and what complexities are those adding, right? So if your business is growing, it's a sign that a lot of end customers are so happy with your app. And when they're so happy, you want to maintain that customer satisfaction. So you would start adding more parts to your tech stack. And when you add it, you're just not adding few frameworks or tools to your tech stack, right? You're also adding more complexity to it. And that's what Govind also was telling in the Atlassian talk, where you keep adding layers, and then the overall complexity becomes more complex, right? And that's what is happening. And when that happens, to look at a simple example, look at an example where a monolith application running on like one VM just have a web application for its customers, serving like 1 million customers maybe, right? And that today is a microservice based architecture running on Kubernetes, running on cloud, also have mobile app, tablet app, also maybe a PlayStation app. And all of this together are serving about 100 million customers. I'm not making this up, by the way. We actually work with a customer who is at that scale. We have a customer who has monthly active users of about 260 million, which is approximately 3/4 of US population, right? They generate about 2.5 petabytes of data, just the telemetry data, not their actual database, actual data. About 3,000 engineers, IPL, people are following IPL. It's like about close to 200 IPL teams, right? And then their uptime so far is 4 nines, right? Which is less than the time it takes to cook Maggi, right? Maggi never gets cooked in 2 minutes, by the way. I don't believe that. I don't believe that. It always takes at least 4 minutes. I've tried it myself. So when that is happening, what are the challenges that these companies as they grow their business are facing? And please note, we are talking about businesses, not just businesses, we are talking about businesses that are going from X to 10X or X to 20X, right? As they scale their business. I'd like to split this into 2 cohorts. First one is business, another one is technical. The business challenges that they're facing are, one is tool sprawl, having numerous tools, and then the cost that they have to pay for all of these tools. And the third one is adoption. From a people perspective, how quickly can they adopt onto these tools, right? And then the technical challenges, lack of interoperability. You have tons of data that's getting generated. Are you able to correlate everything or not? And then you have burdens of scaling. Are you scaling your observability solution, or is it someone else's headache? And then you have high maintenance and security risks. We'll talk more about that one a little bit later. So we have challenges. We also looked at as businesses grow, what are the challenges they have? And we also looked at different patterns of observability. Now let's bring those two together, right? In context of each of this pattern, what are these challenges? First one, tool sprawl, the tool fragmentation that we spoke about. As on today, there are about 27 million engineers across the globe. And these engineers are split across 25 different functions. And when I say functions, I'm talking about front end, back end, DevOps, SRE, information security, whatever, right? And that's not the problem. The problem is each team takes a decision to what tools they have to use, right? You form a new team and then they're like, hey, you know what? Rest of the engineering team, they don't know anything about this. I'm going to bring in this open source solution which got released maybe yesterday, and I'm going to use it because that's awesome. I want to use it, right? And what is happening because of this is when there's a production incident, every team is using their own tool, right? So the overall time that it takes to fix or get to the root cause of an incident is way higher. That's where you're leaking the revenue of your company. At the same time, your engineering teams are spending time running through multiple tools. That's affecting your engineering velocity. At the same time, you also pay the cost for these multiple tools. And if you look at the patterns, DIY is certainly in red. And you know the reason, because there are already multiple tools. SaaS providers, most of the vendors or commercial tools that are available have a very consolidated solutions that they comprehensive solutions that they come up with, where they can take any kind of data and then they can manage it just in one tool. Cloud and hybrid, just like how I told you earlier, every time you get into cloud, it's not addressing all of your use cases in one screen. There are multiple services. And hybrid, anything that is not green in the three before, your hybrid is going to be not in green for sure. But what's the solution for this? The solution for this that you have to consider, that the organizations have to consider, is a pattern where all the observability use cases are addressed in one place, right? And the next one, high cost and complex pricing. Just like how I said, the engineering teams are growing, along with basically as you add, if you're running a monolith on one VM, one ops person is okay, right? Then you move to Docker. One ops person is not going to do anything about it. You need another ops person, right? And then you move to Kubernetes just because you want to be in the rat race. Forget about uptime. I don't care. Everyone else is doing. My competitors are doing Kubernetes, so I'm also doing it, right? You do that, and what happens? Your ops team is in pressure. You need more ops. You need more people in your ops team, right? And that's the hidden cost that no one talks about. Everyone tells, "Hey, I'm running on Kubernetes today. Everything is running super smooth," but what are you paying for it? And the second thing that I want to talk about cost is when you go to a commercial vendor, the number of line items that you sign up for in the contract can grow as you start using more and more types of data, right? And more instrumentation that you add different layers of your tech stack. And the next one is unpredictable pricing. If you are signed up with a commercial vendor, there are commercial vendors who come up and then they say, what, you scaled your system for 2 hours this month? Why did you do that? I'm like, yeah, I had a sales season, so I scaled up for 2 hours. You know what? We're going to charge you for the whole month for those 2 hours, right? That's what a lot of commercial vendors do today. That's unpredictable pricing. And if you look at the different patterns that we spoke about, everything is yellow. There is nothing that is green in this. People might argue saying that, hey, DIY should be green because I'm not paying any cost for this. No, you are paying. That's the hidden cost that we spoke about. Ops team cost there, right? What's the solution here? You have to consider a pattern or a vendor that purely charges you only for consumption. And then ask them, what are the problems that you're facing? Come on, tell us. We are open source. We want to listen to you, right? And all the engineers said, 41% of the engineers said, as my tool stack grows, I'm adding more tools and it's getting super complex. Forget about a new person who is joining the team. The person who is already working in the team can get lost in all the tools, all the configurations, and all the the GitHub repos that I already have maintaining this. And another challenge is, which is very much related to the first one, yes, it is getting complex, but if I want some support, I don't have a dedicated support, or there is no super detailed documentation, right? Because open source is completely based on collaboration, all volunteer, right? People voluntarily come and contribute to it, and you can't expect a volunteer to come and then do it for sure, right? It's up to them. I'm not doing it today. It's Saturday. I'm not doing it, man, right? And when you look at the different patterns, DIY is definitely falling short there. But SaaS and cloud are the ones who have dedicated support, great documentation, and they also have, even if they're adding complexity, it's like adding more features for you, right? So as a solution for this one, the pattern that you have to consider is for a vendor or a solution who have a strategic roadmap that is defined on how they want to grow their product without impacting what they're already doing, right? At the same time, you should also look for a vendor or a pattern that has a streamlined support structure that's already there, and a documentation that is evolving every single day. And the next one now comes to the technical part. There is a production incident, right? One of my SRE friends or DevOps friends here is trying to debug the issue. They would come, log in into the screen and then say, I have 20 questions. Am I getting answers for all 20 questions in the same screen? I'm not sure. I may get or may not get, depends on the pattern that I'm following. If you're following DIY, in DIY, basically all the data that you have is going to different tools, entirely different tools. So basically the engineer who's trying to debug it is the glue. It's his responsibility to say, okay, I have metrics here, infrastructure, there is a CPU spike, and now I'm going to my tracing tool, looking what's going wrong, what is the hotspots in the trace. Is this happening at the same time? Let me go take both the snapshots, put them next to each other and then check it, right? So you are the glue. That's what happens in DIY. SaaS is where most of the vendors today are taking data from different data sources. They are putting the efforts to consolidate everything, bring everything in context, right? And keep everything together so that they can give you answers faster. And this is what happens when you have a business running at scale. You need answers faster. You can't wait for the answers you can't spend a lot of time to get the answers. So here's the solution. Like I was telling, you need to consider a pattern where all different kinds of data is treated in the same way and brought together. And then the burdens of scaling. I took inspiration from my understanding on big data and the 3 V's, right? How much is the data getting generated? And I also took a freedom here, and then which kind of resource is the one that's getting impacted for each of these V's, right? So now DIY is definitely right here because you are the one who's scaling everything, right? You are responsible for scaling stuff, maintaining it, but at the same time, the SaaS and cloud solutions that you can pick up, it's their headache. They are the ones who take care of scaling the systems, maintaining the storage, be it storage or compute, it's their responsibility. But when it comes to network, people may ask saying, hey, I'm still sending data from my network to their network. Am I not paying for the network bandwidth? Maybe you are, but all the SaaS and cloud solutions are also coming up with some innovative capabilities so that they can save cost for you. And the last one is maintenance and security risks. 125% is the number of security breaches that got increased since 2021, right? And it is projected that there are going to be 28,000 CVEs by end of this year. And thanks to COVID, because all the businesses are trying to go digital, the hackers are looking for loopholes in every single possible. And do you want to take that responsibility? Because you are already scaling your systems. You are already ensuring that the security is taken care for your existing application. You really don't want to spend time on, securing your observability solution also. And that's where day 1 and day 2 operations come into picture. For all my friends who are in ops teams, day 1 deployed, set up everything, done. Day 2 is when the struggle starts, right? Day 2, you continue to do the deploying, you continue to maintain the setup, but at the same time, you have to monitor it. And if something breaks, it's your responsibility to troubleshoot it. Do you want to take that headache? I don't really think so. You should not be doing that, right? And by now you already got used to the color coding. I'm not even explaining that. So now, forget about the scale that we are seeing, right? And also the different patterns that you can consider. The first thing that happens here is as your application is getting more traction, what happens here is the end customers start comparing your application with the performance of all the apps of the Mangs of the world, right? They say, hey, on Meta, I'm able to get this kind of performance. Am I getting the same performance here or not? Right? Or Amazon is so good. Why is this not good? So getting your customer satisfaction till that 95th percentile is fantastic. But for you to also get the 95th to 96th percentile also to be of the same level of satisfaction, that's the toughest part. And that is where you'll need a powerful observability solution, right? So completely ignoring the scale or the pattern that you work at, There are a few pitfalls that every single organization also falls into, right? And the kind of pitfalls that we see, irrespective of the pattern and scale. The first question people would ask is, do I really have to instrument everything in my stack? The short answer is yes, because if you do that, you are basically, if you're not instrumenting everything, there is a lot of data leak that is happening. And that data that got leaked could be the most powerful data point that you might need, right? If you're following the first principle philosophy to debug your production issue, right? You looked at the symptoms, you're looking at what caused the symptoms, you're trying to validate it, and you're doing the validation and causes back to back in an iterative fashion to go to the root cause. But you may get stuck in this at any given point in time if you do not have the complete data captured at all layers of your system, right? So the short answer is you have to instrument front end, back end, infrastructure, everything, right? But at the same time, capturing the data, is that good enough? You captured the data and then just leaving it there is like cooking a nice meal, leaving it on the table and not eating it, right? That's where you need a powerful observability experience, which can help you get the most potential out of your data that you captured, and also build dashboards, set up alerts, right? And also help build some service levels for our SRE engineers here. This is all about after going to prod. So now let's talk about before going to prod. Observability driven development is a very big buzzword that's going on in the market right now, right? And the definition that is given for this one is, people say, if you instrument your code before it goes to production, that is observability driven development. I don't believe that. What I believe is making sure that you have the instrumentation done, and at the same time making sure your code is performant and bug free before it goes to production, right? That's observability driven development. And the last one is, you might ask, Ganesh, this is all good, you're asking me to instrument everything pre-prod and prod, which is awesome. There's going to be a lot of data that gets generated, right? How do I treat the data? That's where you tell, these are the questions that you need to ask yourself. How granular you need the data to be? How detailed should it be? How long do you want to retain the data? And a simple example here, quick example of an e-commerce application. If you're doing online browsing, you don't need so much of granularity and detail there, but you need the data to be retained for longer because you need it for business analytics, right? And you might need the volume is going to be super high. But when it comes to order placement, you need so much granularity and detail, but you don't want to retain it for longer than a week because the order is already delivered by then, right? So now, how to get efficient with New Relic? We spoke about a bunch of challenges and how the business grows. So now let's talk a little bit about New Relic, right? Because I'm supposed to talk because I come from New Relic. I don't have an option, right? Okay, so New Relic is the leader in the observability industry, and we are the inventors of APM. We have been in the industry for the last a decade, more than a decade, and we just didn't sit there with APM. We evolved our solution by adding more and more capabilities every single day. And as of today, we have 30 plus capabilities that can serve any team, any technology in any environment. And we capture data in four different formats: metrics, events, traces, and logs. It could be coming from a New Relic agent, or it could be coming from an open source agent as well. We don't care. We treat all of such data in the same way. And once we have the data, just like I said, we don't keep capture it and then cook the meal and then leave it there. We actually also serve it to you like a good buffet, right? What we do is we build full stack observability experiences on top of all this kind of data, be it from front end, be it back end, infrastructure, database, anything. And on top of it, we also extended the platform so that we can give better user experiences, right? Like for example, we have a developer experience capability within our platform, which is CodeStream, right? Recently, we acquired CodeStream a couple of years ago. And what CodeStream is a collaboration tool where a developer can actually submit PRs, do all the feedback requests to his team members, check the errors that are getting generated for the same service in production, and also look at all the golden signals from New Relic in their IDE, like literally in their IDE, right? In their IDE, they can actually see all the golden signals that are getting generated by this piece of code, everything in this place, right? Basically, we want to make observability a daily practice for all the software engineers. We don't want to limit ourselves to SRE or DevOps, but for everyone, including the developers. So now you might ask, Ganesh, this is awesome. You're generating a lot of data, but is New Relic not costly? Right? I'm not answering that question. I'll let the experts like Gartner answer that question. Right? And what Gartner said here is, they said New Relic's pricing is the most disruptive and transparent pricing in the market, right? So my request to you guys, go to New Relic, sign up for an account, and you get a free tier which is free forever. We don't ask for credit cards. It's free forever, right? Log into New Relic, sign up, see the power of all the data that you're seeing, get the best out of all this, all the data that you're sending us, and take us on the observability journey with you guys, right? And let's build bug-free software and still not break your banks. Thank you so much. Those are my credentials.